Question number 7. A solid cylinder of mass m and radius r is released from rest on an inclined plane. Okay, this is a hexagonal portion. The cylinder rolls without slipping, rolling rotation. Moment of inertia of the cylinder is half mr square. The speed which when it reaches the bottom of the cylinder is v. So when it reaches here, its speed is v over here. What is the vertical height from which the cylinder was released? What is the vertical height? This is the question. How do we solve this? Now, you can use conservation of energy here. Okay. What is the initial energy here? The initial energy is equal to mgh. You just kept it in your hand and you did not release it. You just kept it like this over here, right? Mgh over here. When it came here, what was the energy? The final energy here is nothing but half mv square due to the center of mass position. At the same time, this is now spinning around its axis, right? So therefore, this should be half I omega square, the rotational kinetic energy plus the potential energy. What is the potential energy? Mg into what is the height? Height is 0 over here, which I will write this as a half mv square plus half into what is the value of I? I value somewhere it was given half mr square. So half mr square multiplied by omega square v square by r square, right? This r square and this r square goes away. So what I am getting here? Half mv square plus half into half is 1 by 4. 1 by 4, there is a m here, there is a mv square here. mv square over here, which should now be equal to 3 by 4 my square. Now what should I do? This is your final energy. Now I can equate these two because no energy loss, right? So therefore I will now write this as E final is equal to E initial, so which means 3 by 4 mv square is equal to mgh. This m goes away. I want the value of h here. So h should be equal to 3v square divided by 4g. I have to pull this g downwards and I get the answer. That's it. Okay. So 3v square by 4g, which is the answer B over here.